All right, guys. So today, let us start off with a nice, easy concept, and that is going to be multiples. So all of this information is lesson 37 of your notes. And lesson 37 is in week 11. All right, so multiples. What is a multiple? Well, a multiple is related to the word multiply. And essentially, you are taking the number and just multiplying it on and on and on. In the sense that if I look at the multiples of 3, the first multiple of 3 is 3 because it's 3 times 1. Next multiple of 3 is 6 because it's 3 times 2. Next multiple is 9 because it's 3 times 3. Then it will be 3 times 4, 3 times 5, etc., etc., etc. Please make sure that you always start with your first multiple as the number itself. That's very important. Okay. And the idea of this multiples is going to be used towards a lowest common multiple that we're going to be coming to a little bit later. So if I do one more example, so multiples of, and it can be anything, let's go 15. Multiples of 15 would be 15, 30, 45, 60, 75, etc., etc., etc. And this is 15 times 1, 15 times 2, 15 times 3, 15 times 4, 15 times 5, etc., etc. So you're just adding on the value that you are taking the multiple of each time. So you add 15, add 15, add 15, add 15, or add 3, add 3, add 3, add 3, etc. All right. Not a huge strain mentally here. So we can add these quite nicely. What about if I have a look at a factor? Well, a factor is slightly different. So a factor is a number. No, not a number. It is a number that divides into another number with no remainder. So for example, if I take the number 8 and I want to find out what are the factors of 8. I'm saying what numbers divide into 8 without a remainder? Well, can I divide 1 into 8? Because I could have 1, 2, 3, 4, 5, 6, 7, 8. And factors are only whole numbers that we're looking at. Does 1 divide into 8? Well, yes, it does, because 1 divides into everything. Does 2 divide into 8? Yes, it does. Does 3 divide into 8? Well, 3 has a remainder when it divides into 8, so no, it is not a factor. Is 4 a factor? Does it divide into 8 nicely without a remainder? Yes. What about 5? Well, no, there's a remainder. What about 6? Also a remainder. 7, there's a remainder. And 8 itself does go in. But having to write out every possible number is a huge mission. So there is an easier way of doing this. And it comes about through knowing something called factor pairs. And factor pairs are two factors that multiply to give the original number. So for example, 1 and 8 are factor pairs, meaning that 1 times 8 gives me 8. Also, 2 times 4 would give me 8, and therefore 2 and 4 are factor pairs. So what I can do is, if I find one factor, I know automatically that there must be another factor that I can combine with it to create this factor pair. And then I won't have to then have a look at that number. Because remember, I looked at 1 and I looked at 8 and I tested both of them individually. If I looked at 1, tested it, found it worked, and then found what number I must multiply 1 by to get 8, that number automatically is going to be another factor. So let us have a look at another factor example. So what about if I say to you, find the factors of 24. So let's start at 1. 1 is there. 1 divides into 24, great. But I automatically know that 1 times something gives 24. Well, that something is 24. So now, from finding one factor, I've actually now found 2 factors. What about 2? Does 2 go into 24? Yes. Do we stop there? No, because we know that 2 is part of a factor pair. 2 times what gives 24? 2 times 12. What about 3? Does 3 go into 24? Yes. What do I multiply 3 by to get 24? I multiply it by 8. What about 4? Do I multiply 4? Do I divide 4 into 24? Yes. And 4 times what gives me 24? 4 times 6. Is there anything else? Well, what about 5? Does 5 go into 24 without a remainder? No. More importantly, do I need to test any other number above 5? And the answer is no. Why do I not need anything above 5? Is because I've already got this hand side done because of my factor pairs. So it is important and an easy thing to remember that you never have to look higher than the square root of the number. So for example, here the number is 24. So you never have to look higher than the square root of that number. And I will show you why from the next example. So therefore, this is my whole listing and my factor pairs: 4 by 6, 3 by 8, 2 by 12, and 1 by 24. So generally, they'll ask you to list out the factors, then you write it as a list like this, not as a list of factor pairs, please. What if I look for the factors of, let's say, 16? So if we have a look at factors of 16, I know that 1 is there, and because of my factor pair, 16. I know that 2 is there, and because of my factor pair, 8. 3 doesn't go into 16. What about 4? Well, 4 goes in, and 4 would multiply by 4. So do I put a 4 there and a 4 there? Well, no, that's ridiculous, because I'm meant to be listing factors. And I'm not going to list 4 twice. So you only do this once. So your list is 1, 2, 4, 8, and 16. And then your factor pair is 4 by 4, 2 by 8, and 1 by 16. And this is why you never have to look higher than your square root, because your square root is the middle. It is the middle of your listing. So therefore, never, ever, ever have to worry about going higher than that. What about if we have prime numbers? What is a prime number? Well, a prime number is a number with 2 factors. And more importantly, they are distinct factors, and distinct meaning that they are not equal to each other. And these factors are going to be 1 and the number itself. So for example, 17 is a prime number because only 1 and 17 go into that. Every other number that divides into 17 will have a remainder. Something like, let's go 23. 23 is a prime number. The opposite of a prime number is known as a composite number. So for example, 12 is a composite number. So this is more than 2 factors. So all of our previous examples that we dealt with when dealing with factors and our factor pairs, all of those are composite numbers. If you had 24 that we looked at earlier, that is a composite number. What about 1? Is 1 a prime number or a composite number? Type your answers in the chat. All right, and the results are in. 12 to 1 say that the number 1 is prime to composite. Well, what I can tell you is that the people, which is just about all of you, that said that 1 is prime, were thinking along the right lines, because 1 does have 1 and essentially itself as a factor. However, you would be wrong. And here I have all of you going, no, no. And that one little person out there that decided, I'm going to stand against the flow of everyone else saying that it's prime, believes that this is going to be a composite number, is also wrong. All right. It turns out that 1 is neither prime nor composite. And you say, huh? What? Well, actually, the reason for that is because you need both of these conditions to be satisfied for it to be prime. So, does 1 have factors of 1 and the number itself. Yes, 1 and the number itself being 1 are factors. 1 times 1, great. Does it have 2 factors? Well, 1 and the number itself, great. Are they distinct? No. Remember what I said about distinct is that they needed to be not equal to each other. Which means that the number 1 fails this condition. It does not have 2 distinct factors. Therefore, 1 is a lonesome little guy on his ace, and he is known as the universal number, but he is neither prime nor composite.